Hi, welcome to a new Cube video. My name is Pavel Savyanko, and today I demonstrate you how to use statistic box plot in the CubeGUI and how to work with statistical information over the system tree. Let's do it. Okay, we are back to our terminal, and today I would like to demonstrate you how to work with statistical information over system tree and how to use the plugin SystemStatistics. So for that we start our cube. So here it is, and we open an example of cube file like this one. It's a typical example, is a BT and Z measurement of NAS benchmark, so nothing special. So we see that it's a trace cube file, so we have a hierarchy of metrics, but it is so far not important. So let's select metric time, first the top call tree, and then we have a system tree. That is our point of interest. So if we expand the system tree, for example, we see that it has 256 elements. It's a relatively small system tree, small measurement. Nevertheless, it's a good example to demonstrate. So with larger and larger measurement, the system tree is getting larger and larger. And already here, for example, just taking a look at the values which are very close to each other, it's hard to find, for example, minimal value or maximal value. Like, for example, we see here 4.1, 4.0, 9, 4.1.2, 7, 2, 3, and so on and so on. So here's 4.65. So it is getting harder and harder to actually explore the system tree and to kind of study distribution of values and so on. One can use this drop-down menu here on top. I explained it in one of the previous videos, but it will probably still be not as helpful as one would like to. Imagine you have 10,000 or 100,000, 500,000 of elements, and even the scrolling will be not technically simply not anymore comfortable to use. So, and it is, from another point of view, it is also might be simply meaningless to try to explore the every single value in such large measurement. By such large measurement, one would like to know the key values, like minimal value, maximal value, what is average, how is distribution, where is majority of values, and so on. Such statements are more interesting, and not where exactly which value is located on which thread, on which core, and which rank, and so on. One can pinpoint such individual values, but maybe with another techniques than just exploring the system tree. So one of the way to make such analysis of such large system tree is to simply take a look at statistic of the values over the system tree. So if one just considers this the values in system tree as a set of values, one just gathers statistics over it. So for that we have a plugin Statistics or SystemStatistics. It is our standard plugin, so it should be available by every standard distribution of Cube. If not, one has to take a look in the settings whether it is activated. That is this one. It should be activated, or maybe one has disabled it by accident, so the checkmark should be checked. So, and that is basically the bar plot or box plot, which represents the statistic of values over the system tree, and pretty much that's it. So we see here maximal value, we see here minimal value, we see here average, we see the median, or that is average in this median, we see the quantiles here, and that is basically the info. So we see that majority of values are located on a lower part of the values, so from this range, but the median is still in 4.9. So That's info what we can get out of this box plot. And of course, this statistic is gathered over these values which are now currently in system tree. It means these are values for the selection in the call tree and metric tree. So in this case, it's a metric time and the call tree BTMZ, so that's top. If we select some another values, like for example this one, this is the metric time, but for the call path ADI. And of course the values are different and they might have different statistics. If we take a look, indeed it is different. So the maximum is different, minimum is different, and also the quantiles are distributed differently. If we just expand it, so for example this is exclusive values of ADI, so that shows the distribution of exclusive values of ADI over the system tree. And we see that the values are also the different, the minimals. And of course, if we select simply another metric, for example, MPI synchronization, if we click here, then we see that the values are from 0 to 2. That's probably not a really good metric. But for example, MPI communications, and then if we select some this call, we see that the minimal is 0, maximal is 4020, and majority are on the lower area. So that is the sizes of numbers of communications. We can also take a look at distribution of the data, so it is correlating with the previous metric, and so on and so on. But of course, time has more structure. So that is one. That's basically, that's all what this plugin shows. It shows distribution of values in system tree, and by changing which values one has in system tree, one gets simply different box plot. So like selection here, or that is exclusive value, or it is xsolve value, or maybe that is not the time metric, but for example MPI times, and then it is distribution of MPI times, or it is OpenMP, then it is OpenMP metric, and so, or it is computation, for example. So this is basically display of these values. If one clicks on it, one gets statistics information, gather it as a table. So there is a sum, so total number sum of all values over the system tree, number of these values. So one can build average simply by dividing one of another, and one gets this mean. 90% shows that is how much is that out of the maximum. Maximum is this value, so here is the minimum, so it's coming from 1 to 7, where this median is located, lower quantile, upper quantile, and standard deviation. So this you can clip in clipboard and then put it, so for example, copy paste in Excel sheet or another documents which you would like to create. Another representation of the statistical information is not using box plot but using violin plot. If we select it, then we see here a little bit more information. So violin plot also presents the distribution of values over this range. So we see that the majority, the distribution is skewed more towards the upper values. If we select another, for example, call path, then we see, for example, such a distribution. We see that here is the majority is located around 0.27, but there are some few values in this range, and they are actually defining the maximum. Let's take a look at, like for example, this value. We see such a distribution. So obviously, majority of values are located here. But there is some values which are rather smeared from 0.21 to 1, but they are distributed uniformly, but there are few of them. Majority are located on this. We can take a look, of course, on system tree, and we see that this majority, these are on OpenMP ranks, and the higher values, they are in around of master threads. So there are, but they are more smeared. The OpenMP threads are kind of close to each other. That's the values of execution, but the master threads are having bigger deviation. That's why we have this distribution and this distribution. So the box plot doesn't show this behavior. It shows only that the majority of values are in this range, but maximum value is somewhere here. The violin plot shows this behavior, this distribution, and gives a little bit more of insight about the values in system tree. Another thing which one has to keep in mind that the plugin shows or displays the values in system tree. If we change the value in system tree, we change also display in system statistics. What I mean, like if we go, for example, to this drop down and we select, for example, peer distribution, that will recalculate and rescale the values in system tree, not from minimum to maximum, but from 0 to maximum, from minimum to maximum, and map it into the range from 0 to 100, so like 100%. And then, of course, statistic will go from 0 to 100. It is displayed on the left side. As well, if we select, like for example, own root %, then we see that distribution is squeezed because it is displaying from 0 to maximum to own root %, which is 0.5. But majority of values are located in this range, comparing to the own root %. That is if we modify these values using this drop-down menu. Another element which defines or modifies the values in system tree, these are subsets. This I explained also in another video. So if we just take a look at here, we can have basically all values, or the values which have been or values of elements like master rank, OpenMP, thread 1 to 3, which have been visited. Means the metric visits is not 0, or it can be on the level of process like here, or the threads, which would be the same, thread 0, so like the master threads, or non-zero, so workers, or 3 elements, the nodes, that is this one. And of course, by selecting this subset, one gets different values. Like for example, here we get these 3 nodes. That is the distribution over the 3 nodes, which is not that really meaningful. It is a majority around 38, but maximum is 25, 250. So what is this 250? That is this top, this collapsed one. The other one are this one. So this subset is probably less useful. But for example, knowing the distribution of values over master threads, one selects this thread 0 and one takes, this distribution is looking like that. So minimum is 0.8, maximum is 1. That is the distribution of values on master threads. If we go on here, for example, there is a distribution of the values on threads from 0 to 90i. That is probably not really good call. Let's do this one. So here is the distribution of master thread. That's looking like this, like previous, but distribution of values on workers is looking differently. It's more actually Gaussian. It's coming from maximum, getting so up, so majority are here, and then getting down. So it's way more uniform distribution. We can also take a look at on the level of process, but that would be probably the same or similar to the values over thread 0. Yes, it is maybe the values themselves, they differ, but the distribution is looking very similar. Yeah, not really. Yeah, so by selecting this subset, one defines which values are actually presented or selected in a system tree, and then one takes a look on the statistic over this subset. So default is this all, and by selecting the corresponding call path, one gets different distribution, and so one can analyze the values in system tree even if the system tree is extremely large. That's it for this plugin. I hope you found this information interesting, and please comment, put a question in comments, press a subscribe, also notification, give us a like, and see you next time.